Welcome back, students. Now we will learn the concept of streams and we will see its different types. A stream is a mechanism for moving data between 2 points. Like if you want to move the data from a file to another file, there is a mechanism available that is called a stream. Streams are objects that let you read data from a source or write data to a destination in continuous fashion. There are mainly two types of streams: readable streams and writable streams. Before starting the streams and explaining it more, I will explain you some of the events that generates during the streaming function. These basically events are available for file system also and for streams also. These events are: one is the data. This event is fired when there is a data available to read. Whenever a producer will write the data into a stream, there will be a data event generated. You can catch this event and read that data. Second event is end event. This event is fired when there is no more data into the stream to read. If you have read all the data into the stream, the end event will be generated, that there is no more data to read. Error. This event is fired when there is any error receiving or writing data. If you cannot read the data or you cannot write into the stream, then error event will be generated. And lastly, the finish event will be generated. This event is fired when all the data has been flushed to underlying system, when you have read all the data and the underlying system is closed from where you are reading the data. So in that case, the finish function finish event will be generated. That means end of activity. So these are all events which are generated, and we listen to these events and work accordingly. So till now, what you have studied, you have may have seen the standard streams. We will see those standard streams today again. We will see the readable streams. We will also see the writable streams. And what are those? First of all, let me explain you the stream. Stream is basically just like a buffer memory into your RAM, where you can write some data and another function can read data from there. So that is actually the concept of stream. Standard streams. Node applications are connected to three standard streams. These standard streams are available throughout every programming languages, and you can access those standard streams. By name, you should know there are three standard streams. One is the SDDN. You are using this SDDN in C, C++, Java, etc. in every language. STD_out and STD_error. STDN is actually a readable stream that is deployed by your operating system and available for to gather any user input uh, from keyboard or mouse or etc. So STDN is a readable stream that employed to gather user input. And STD_out and STD_error are writable streams that are used to display output or error respectively. If you want to print something onto the screen, that is, you have to write that thing into std_out, and std_out will print that thing onto your screen. The console.log and console.error family functions are simply wrapper around call to process.stdout.write. That means when we call console.log, alternatively what we are calling, actually we are calling process, a system level function, process.stdout. Stdout is our output stream. Dot write, to write something into our stdout stream, and process.stderror dot write. So for error function, we will write something into the process.stderror dot write. So these are the three built-in streams that are available, that will be that your operating system use and all the programming languages actually use. Whenever you want to display something onto your console, actually you are calling console.log, and on the back of that console.log there is a function that actually calls the process.stdout.write, that writes something into your stdout stream. Now we will take an example of these standard streams so that you can understand. When a node application runs, the std_in stream is in a paused mode or paused state by default. By default, std_in is in a paused mode. However, you can read data from std_in by unpausing the stream and handling data event. So I will explain this code. You can understand it easily. Here what we are doing, we are basically process.std_in.once. This once is a listener function. We are listening on std_in, and what we are listening, the data event. If something will be written on std_in, this function will be executed once. What it is executing, it is taking the data process.stdout.write hello and whatever the data has been provided, and then what we are doing, process.stdin.pause. So this function actually starts from here, process.stdout.write. This will be printed onto your screen. Actually it is console.log. What is your name? And you and after this question, what it is doing, it is actually processing stdin and unpausing it, process.stdin.resume. As I have told you, by default it is in pause state, so we are unpausing the stdin stream. So it means now your node application is in a listening mode on stdin. So then this function will be executed. After printing what is your name, it will listen any input from the user, and we will type the name, and that name will be basically stored into a data, and hello and my name, like for example I write the Rashid, so it will print out hello Rashid onto my screen, and it will again pause my study in stream. So this is a simple function which actually manipulating the std_in and std_out directly instead of calling any middle or wrapper functions. So this is an example of your standard streams. And that thing has been explained in this example. Std_out is used to create a prompt for the username. Then std_in is unpausing using the readable stream resume method. When the user types in their name and presses enter, a data event is emitted. That this triggered the handler which greets the user by name and then return std_in to the pause mode. I have explained it to you. No, these were the your standard streams. You have two more streams, readable streams and writable streams. For the readable streams are source of data. These streams emits data, close, end, and error events, which are used to process the data streams. So the events that will be emitted are data, close, end, and error, which are used to process the data streams. When a new piece of data known as a chunk become available, the stream emits a data event with the actual data passed as a buffer. So whenever you will write something into the stream, it will emits a data event, and that chunk will be available to the other application. The close event is optional and can be emitted when the underlying source of data stream is closed. So you can also listen to that close event, and once the stream has sent all of its data, the end event is emitted. Like if a request has been sent to the user, the end event will be, you will be listening the end event, and after end event you can perform ahead. After an end event is emitted, no more data events should be emitted. If anything goes wrong, the stream emits an error event. No, this we have to create a readable stream. we have a method fs.createReadStream method. This method opens a file as a readable stream. Create a read stream reads a readable stream based on the file name passed in as an argument. Like in this example, you can see require fs. We are requiring the fs and footer text fs.create read stream, and we are creating the stream of this file. Now you can ask me a question: why we should use the stream instead of a read file function? Actually, when you have a lengthy file, a heavyweight file, there is an issue with read file. Read file function actually open the complete file into your RAM, and it can be high memory utilization. So it will copy a great chunk of data into your RAM, and alternatively huge space of RAM will be utilized when you use read file. For example, if you have a movie file and you provide that file as a read file, it will take a huge amount of your memory to execute the command. While in case of fs.create read stream, it will not open the complete file and copy that into RAM, but it will write a chunk into memory. And when that chunk will be read, next chunk will be written, and so on. So the data will be passed to other system chunk by chunk. That chunk is actually defined. You can see, you can run fs.create restream and check your network operations and your file, your RAM coverage, the process information, and you will come to know the exact size which create restream is taking. So what we are doing, a read file will open complete file and can be high memory usage. So that is why we use create read stream if we are working with heavy files or files with GBs of capacity. So we use create read stream. It will not impact your system at all. So we are opening the file as a read stream, then we are listening on the file as a data event. Whenever there is a data event, whenever there is new data into the RAM, it will be read and it will be written into process.stdout.write. We are actually copying all the data into process.stdout.write, writing that into the standard stream from read stream. And when there will be an end event, that means there is no more data into food or text, all the data has been basically read. In this case, what we are doing, console.log. I told you in last slide that console.log is wrapper function against process.stdout.write. So alternatively, it will print out all this data onto your screen at once. So we are simply we are simply printing out the content. But in the actual example, we will manipulate that data and we can use that data for some other purpose also. So we can in this example we can see we have applied one event, we have listening on to another event, and we are listening on another event. If there is an error, we are printing that error. So we are listening three methods, whichever the basically sorry events, listening three events, whichever event will be called, that method will be executed accordingly. So that has been explained. There is another example. You can see fs required fs. We are specifying data as an empty data. We are opening a read stream, create read stream. We are creating the read stream. We are specifying the encoding scheme. If you want to set the encoding scheme, it is UTF-8. Then we are listening on data. Whenever there is a new data, it will be attached with the current empty data, and so on. So we are basically adding up the data chunk by chunk and writing it into the data field. And then when there is the end of data, we are just printing out the data here. What are writable streams? Writable streams are used to write data onto another file. Readable streams are destination or sinks for data. Data is sent to a writable stream by calling its write method. Once all the desired data has been written, the stream end method is used to signal the end of the stream. You have seen an example of writable stream when process.stdout.write was invoked. It alternatively writing the data into stdout. Like readable streams, writable streams also emit close and error events that behave in the same fashion. The same type of data you can see. This is what we are doing. Fs, we are requiring the fs module. Then we have actually a data variable which we want to write into a writable file. So we are opening a file, right, output.txt as a writable stream, and we are writing the data, this data into this stream. And whenever we will call the writer stream.end, it alternatively write all the data into actual file. It will close the stream and write all the data into our output.txt file. So write stream.end method actually what it does, it actually flush all the data to actual file. Before that, all the data is actually being written into the stream only. It is the same concept like when we close the file, then we actually the all the data has been will be written into the file. So here we are working on finish, write complete or error. We can actually print out the error. So this is an example of writable stream. But there is an issue. A writable stream can only handle so much data at one time as underlying buffer may become full. If you are writing into a writable stream, but there is no one to listen to basically or reading that data, then the stream will be full. Once this limit is reached, the stream is saturated and any additional data written to the stream can cause problematic or unpredictable behavior. This is called, this scenario is actually overflowing and overflowing the data. Back pressure is the way writable stream signals to its source to stop sending data. As back pressure is actually a mechanism with which a writable streams tells its writer that you should not write more data till the time the current data is read by some file system. Back pressure is implemented by the write method boolean return value. Whenever you call write stream.write, it actually returns a boolean value. If this value is false, the source should not write any more data to the stream. That means the file, the writable stream cannot take more data. So the writer or the source should stop writing more data. This gives the writable streams time to process the data that has already been written. Once the stream is ready to receive more data, it emits a drain event. There is another event that is called drain, and you will be listening on this drain event somewhere into your code. And if there is a drain, you can reset the data. You can again write into the writable streams. This is little tricky mechanism. To avoid this tricky mechanism, there is another concept, that is the concept of pipe. Piping is a great mechanism in which you can read data from the source and write to the destination without managing the flow yourself. You don't need to worry about actually the back pressure or other issues. Every issue will be solved using the pipe. There is no limit on piping operation. So if you want to read a file and you want to write that content into another file, there is a simple function for that. Like fs, we are requiring fs, we are creating a readable stream, we are creating a writable stream. We are opening this file to read, we are opening this file to write. And what we are doing, readable stream dot pipe, we are piping this file into writable stream. So alternatively, it will copy all the content of this file into this file. So a copy function is so simple. of these 4 lines, 3 lines. By writing these 3 lines, you can copy a huge file into another file without overloading the memory. This is so simple. And you can pipe to actually anything. You can pipe to browser, you can pipe to file, etc. fs.read file, we have seen this code. Fs required fs read file, write file, pipe. You can a readable file system is used to read data from a file. The data from the readable stream is then sent to the writable stream automatically using the pipe method. This code performs the file copy system. Pipe method allows the output of one stream to be connected to the input of any other stream. This saves the developers the hassle of handling a variety of stream related events such as rain, etc. So it is very simple. Chaining the stream. You can chain the stream. You can send the output to multiple stream, or you can chain the stream. This is a very good concept. Like in this case, you are sending the input of you are sending this file, create file stream input.txt, and you are piping it to this function, and the output of this will be piped to this function, and uh, that file is actually a create write. So alternatively, you are chaining the output. The output of one process will be the input of another, and the output of that process will be the input of another. So you can chain this, and you can separately pipe to different sources. Like if you want to pipe something into a text file, and you also want to pipe to some node.js browser application, so you can pipe to both things. So both mechanisms are available. We will see in examples. Some useful methods: readable.pause, readable.resume. These methods are unpipe if you want to remove any source or destination piping. So these are the three methods. Pause will stop the stream from reading. Resume will resume back to reading the file, and then pipe will remove destination stream from pipe destination. So these are some useful methods. So that is all from the streams. We have seen our standard streams, that is std in, std out, and std error. We have seen readable streams, we have seen writable streams. Streams are a very good mechanism to handle the files. Instead of create file or read file or write file, those methods actually are memory consuming and takes more memory. So instead of that, streaming is much more flexible mechanism. It basically occupies a least memory into the RAM, and it reads chunk by chunk. And pipe is a great mechanism to copy data from one source to another. This is a very good method with which you can read a full file and send to the browser or to your end user. So we will come with the third part, and we will see how these file system works.